Good morning. Well, we're back, and this week our topic is going to be integers and order of operations. Ms. Renee and myself will be presenting this lesson to you. We will be starting with integers, and hopefully most of you remember what they are, but I'll give you a rundown.
Today we are working with integers. So you have briefly touched on integers in the 5th grade and some in the 6th grade, got deeper into it in the 7th, and now you'll use it forever. What exactly is an integer? It is a set of numbers that includes positive numbers, their opposites, which we call negative numbers, and 0. It looks like this as a set: parentheses, 3 little dots, your negative numbers, 0, your positive numbers, 3 little dots, close parentheses. The parentheses signify a set. The 3 little dots means those numbers go on to infinity and beyond, just like in Toy Story. So this is what the integers look like. So what does it look like on a number line? Let's construct it. Integers on a number line. I always put the 0 first. All positive numbers go to the right of 0. So this is 1, 2, 3, 4, and we can go on forever. To the left of 0 are always your negatives. So this is a -1, -2, -3, -4, and then the little dots. That's what integers look like on a number line.
Okay, so mathematicians have decided that they needed rules so that way everybody does math in the same order and same directions and whatever. But anyhow, it made sense. So they had rules that applied to solving problems using integers. But these same rules also apply to mathematical problems with fractions, decimals, and variables. Today, all we're going to talk about is rules for integers, including addition, subtraction, multiplication, and division. You will see that this little slanted line I'm using as division because that's all the computer would let me do. But remember that the fraction bar means division. This is also a fraction bar. So let's get started with the rules. The rules for addition of integers. Like signs, we simply take the numbers and keep their sign. We add them together and keep their sign. I have a positive number plus a positive number plus gives me a positive answer. If I have a negative number plus a negative number, 2 negative numbers added together give me a negative answer. Adding the numbers, negative answer. Let's look at the number line and see what it looks like there. If we have like signs, okay, the problem I just gave you, 5 plus 3, we said equals a positive 8. So on my number line, I start at the positive 5 to the right of the 0. I'm going in the positive direction because I'm adding a positive number, and I'm going to the right 1, 2, 3 spaces, which gives me a positive 8. If I'm adding like signs that are both negative, notice I put parentheses around my negative numbers. That is so that I don't forget that that sign is there. A lot of times you miss the sign, you don't catch it, you forget it's there, whatever. By putting parentheses around it, I make sure I know that there's a negative number in those parentheses. So a like sign, like signs, 2 negatives, add them together, gives me a negative number. This time on my number line, I'm starting at -5. I'm adding to it a -3. Negative numbers go to the left. How many spaces? 1, 2, 3. So my answer is a -8. So to recap, like signs, two positive numbers added together give me a positive answer. Two negative numbers added together give me a negative answer. I add the numbers. Miss Renee, let's try working on the board now, showing them the disk. Okay, let's model it using our little disk here. All of my blue disks are going to be positive numbers. All of my yellow disks are going to be negative numbers. Here's the same problem I gave you when we did the number line. A +5 plus a +3 equals a +8. If the rule applies, like signs, positives, two positives, give me a positive answer. So if I take 5 blue disks and add to it 3 blue discs, notice they're all the same color because they're both the same sign. So then we add them. 1, 2, 3, 4, 5, 6, 7, 8. And they're both blue, so I'm using the positive sign. So that shows you what that means. Two like signs, add the numbers, and take their sign. So what happens if we have two negative numbers? Those are the same kind of sign, correct? So the rule is, do you remember? Now we're adding two negative numbers together. And we said that we take the negative numbers, -5, yellow is negative here, and we add to it a -3. Oops, that one fell. Now notice they're all the same color. They're all the same color, so we're adding them. 1, 2, 3, 4, 5, 6, 7, 8, and they're yellow, so we take the sign of the yellow, which is negative. So like signs, add the numbers, and take the sign.
All right, now we're going to talk about subtraction of integers. It's a little different in that there is a shortcut to learning what to do with subtraction. We use the term keep, change, change. Before you can start to do a subtraction problem, you must do this. You keep the sign of the first number. You change the operation from subtraction to addition, and you change the sign of the integer following. So keep, change, change is a shortcut to start subtraction. So let's see how this happens. We have a 5, which we're keeping. It's a +5. We're going to keep it as a +5. We are now going to change subtraction into addition. And we have a -3, which we are changing to a +3. Well, look at that. We now have addition of integers. Subtraction of integers. Remember the shortcut. Keep, change, change. This is what it looks like. 5 positives minus 3 negatives. Keep, change, change. So it tells us we're going to keep these 5 positives. We're going to change subtraction to addition. And we're going to change the -3 to a positive. Okay, so when we did keep, change, change, this is what we ended up with. 5 plus 3. Notice, both of them are positives. We are adding now. And the rule for addition is if the signs are alike, you add the numbers and take their sign. So if we add 5 and 3, we know that's going to give us 8. And since they're both positive numbers, the answer is a +8. So 5 take away or minus A negative 3 is a positive 8. Okay, we talked about addition with like signs of integers. Now we're going to talk about addition of unlike signs. Let's model this, all right? We have 5 plus a negative 3. Once again, remember I put parentheses around that negative 3 so I remember that there's a negative sign there. So I have 5 plus a negative 3, and the rule is subtract the two numbers and take the sign of the absolute value of the higher number. In this case, which looks greatest to you. You'll understand absolute value a little more later. So if I have 5 and I have 3, each time I compare a positive with a negative, it gets rid of that number. Look what I'm left with. I'm left with a positive 2. So 5 plus a negative 3 is a positive 2. It's that simple. Unlike signs, subtract the two numbers. 5 take away 3 is 2. And you take the sign of the number that has the greatest value.
All right, now we're going to move on to multiplying and dividing integers. First, we're going to start with multiplying integers. When you have like signs, a positive and a positive, or a negative and a negative, your answer will always be positive. So it doesn't matter if you have two positives or two negatives, your answer will always be positive. For example, we have 5 times 3 equals 15. It can also be written as 5 parentheses, because we know parentheses means to multiply, equals 15. When it's written with negative numbers, same thing. Negative 5 parentheses negative 3. So that means to multiply, and that does equal a positive 15. So just remember, anytime your signs are the same for both numbers, your answer will always be positive.
Okay, if we have unlike signs, so we have a positive times a negative or a negative times a positive, our answer will always be negative. It doesn't matter if we have the negative sign as the first number or with our second number. So 5 times negative 3 equals negative 15, or if it's written 5 parentheses negative 3 equals negative 15. And then we have negative 5 times 3, which equals negative 15, or negative 5 parentheses 3, and that equals negative 15. So just remember, it can be written either way. When you have unlike signs, your answer will always be negative because it's a little different. If your signs are the same, your answers will always be positive. All right, next we're moving on to division of integers. Now, luckily for you, the sign or the rules are the same for dividing integers as they are for multiplying. But you will see a fraction bar whenever you are dividing integers. It can either be written slanted like Miss Sonia said, whoops, sorry, or it can be written as an actual fraction bar that way. Either way, it still means to divide. So we have our like signs, 15 divided by 3, which equals a positive 5. Or if we have negative 15 divided by negative 3, it equals a positive 5. Okay? So either way, it still means the same thing. When we have unlike signs, our answers are always going to be negative. 15 divided by negative 3 equals negative 5. And then we have negative 15 divided by 3, and that equals negative 5. It doesn't matter where our negative sign is in the numerator or denominator. As long as we have a negative sign, our answer is going to be negative when we're dividing a positive and a negative. All right, so just remember, when you're multiplying and dividing integers, your rules are the same for both, and you will not have any problems. Next, we are moving on to order of operations. Now, we all remember PEMDAS, which is parentheses, exponents, multiplication, division, addition, and subtraction. But as we move into middle school, we start to learn that there are more rules that need to be followed. And then there is a higher math grouping for algebra when it comes to PEMDAS, okay? When we are doing that, we see GEMDAS, which means groupings. And that's whenever we have 3 different ways of grouping. We have our parentheses, which is our first way. We have our brackets, which is the second, and then we have braces, which are the third. And these are the hardest for me to write. So those are braces, our brackets, and then we all know our parentheses, okay? When we're working with these, we work from inside out, all right? Inside out. And one important thing that we need to talk about whenever we're doing PEMDAS or GEMDAS, with multiplication and division, these kind of go together, and our addition and subtraction go together. So we're going to be looking at them, and when we're solving, we're going to do whichever comes first. So first from left to right. So it's just like whenever we're reading left to right, all right? And we'll have an example of that in just a minute, all right? PEMDAS and GEMDAS. So let's go ahead and do a couple examples. Now, online, if you downloaded this actual paper, you'll see that this exponent is missing because we couldn't figure out how to get it in there. So make sure you go ahead and write the exponent 2 on your paper for that one and for this example as well, okay? That way you can make sure you have it written correctly. Now, when I work it out, I'm going to write it out as a fraction this way. So 6 divided by, we have 8 minus 2 in parentheses, minus 3 to the second power times 2 plus 5. Now, all I did was rewrite the problem out for me, okay? The first step when we're doing an order of operations is the P, which is parentheses. I'm going to put an underline, or I'm going to underline it because that's what I'm doing first. So I have 6 over, what is 8 minus 2 is 6, and I'm going to bring everything else down. Minus 3 to the second power times 2 plus 5. Now my next step is exponents. So I'm going to underline that. I'm going to bring everything else down. 6 over 6 minus 3 times 3 is 9 times 2 plus 5. Okay? Now we're going to look to see, what do we have here? We have division, we have subtraction, we have multiplication, and we have addition. All right? So what are we going to do next? All right? We're going to do multiplication next. So we have 6 over 6 minus, what is 9 times 2? 18. And then we have plus 5. Next, we're going to do 6 over 6, or 6 divided by 6, which is 1. So I'm going to work over here now. 1 minus 18 plus 5. Now we have subtraction and addition. And in our introduction to PEMDAS, we always do addition first. But now we're going back to new rules, addition and subtraction, but whichever one comes first from left to right. So we see that subtraction comes first. What is 1 minus 18? We just went over this with Miss Sonia. This is subtracting integers. Keep, change, change. So we know this is going to be 1 plus a negative 18. What is 1 plus negative 18? It is negative 17. And then we're going to bring down our plus 5. Negative 17 plus 5 equals negative 12. Okay? Did you need to add anything to that, Miss Sonia?
Nope. That sounds good to me.
Okay.
Remember those integer rules.
They always come back to haunt you. All right, our next example is going to involve GEMDAS. So we have our brackets, our braces, all of these funny little things here. All right, we're still going to follow our same rules, and we know that we're going to have to do parentheses first. I'm just going to underline that. Bear with me on my braces because they don't look very good. All right, so we have our 3, and then we're going to have inside our brackets, what is 14 divided by 2 is 7 minus, and then we have 2 to the second power, our brace, minus 2, I'm sorry, our bracket, and then our brace. Those things look crazy. All right, now we have our exponent inside. Now we need to do that next. What is 2 to the second power? 2 to the second power is 4. So now we're going to have 7 minus 4 inside our brackets, minus 2 on the outside. I need to put my brace here. All right, next we're going to do what's inside our brackets. So we have 3, and then what is 7 minus 4 is 3, and then we have minus 2. Now, 3 times 3 is 9, minus 2 is equal to 7, okay? You just have to remember to follow all of the rules in doing your parentheses and then your brace or brackets and then your braces. You're working inside out, okay? Now, on your downloads, you're going to have a paper that is just practice on adding, subtracting, multiplying, and dividing integers. We kind of set them up as to be written as parentheses for multiplication. You have it written this way for division as a fraction, also written this way as a fraction. Okay, pay attention to your signs. And then there are a few problems on the back for order of operations, including braces and brackets, exponents, all of it, okay? Make sure you practice, that way you are prepared, okay? Want me to do that in part 2? Okay. All right, so learning integers, rules, and order of operation procedures are the 2 most important math concepts as a middle school math scholar. Remember that we always said multiplication and division were your foundations coming into middle school. Integers are pretty much your foundations moving forward. So make sure you download your practice problems. Make your integer foldable. We did put one of those online also, and that's going to help you remember all of the rules that you need. And then also do your practice problems, okay? Have fun with integers. You can go to khanacademy.org for more problems, and stay tuned for next week when a new concept will be presented. So the perfect squares say, stay positive and keep your negative thoughts to yourself.
We are the Perfect Squares signing off. See you next week. Bye.